Hello everyone, welcome back again. In our previous video, we saw how limits could help us represent and work with infinitesimally small numbers. And hence today, we shall continue exploring calculus and learn the most important topic in it, derivatives. So derivatives are the rate of change of a function. They tell us how fast a function is changing at any given point. Geometrically, derivative represents the slope of the tangent line to the function at that point. Let us understand this with an intuitive example. Imagine a function f of x. We want to calculate the rate of change of this function. First, we have 2 points on the graph, a, f of a and b, f of b. The straight line joining these 2 points is called a secant line. The slope of this secant line is given by delta y by delta x, or change in y by change in x, which can be written as y2 minus y1 by x2 minus x1. Let's simplify. X2 can be written as x1 plus h. Therefore, the slope of the secant line becomes y2 minus y1 by x1 plus h minus x1. Positive x1 and the negative x1 gets cancelled out, leaving us with y2 minus y1 by h. Since y equals to f of x, y2 equals to f of x1 plus h. y1 becomes f of x1. So the slope of the secant line can be given as f of x1 plus h minus x1 by h. Now what if we wanted to find the slope at a single point? We need to make the distance between the 2 points and therefore h incredibly small, approaching 0. But we can't directly calculate the slope when h is exactly 0. This is where limits come in. We can find the slope of the tangent line by taking limit as h approaches 0. Limit of h as h approaches 0, f of x1 plus h minus f of x1 by h. This is called the first principle formula for derivatives. This formula tells us that if you zoom in sufficiently close to any point on a curve, it will appear to be a straight line. The slope of this local straight line is the derivative of the function at that point. Now, will we need to calculate the derivatives for everything we encounter? No. We have ready-made standard formulas developed for our ease. Here are some of the standard derivatives. Power rule. Derivative of x raised to the power n is n times x raised to the power n minus 1. Constant rule. Derivative of a constant is always 0. Constant multiple rule. Derivative of c times f of x is c times derivative of f of x. Sum or difference rule. Derivative of f of x plus minus g of x is derivative of f of x plus minus derivative of g of x. Product rule. Derivative of f of x times g of x is f of x times derivative of g of x plus g of x derivative of f of x. Quotient rule. Derivative of f of x by g of x is equals to g of x times derivative of f of x minus f of x times derivative of g of x by g of x squared. Derivative of sine is cos x, derivative of cosine is negative sine x, and the derivative of an exponential function is the same exponential function, and the derivative of natural logarithm is 1 by x. These are some of the most fundamental derivative formulas that are frequently used in calculus. Let us take an example. Find the derivative of the function f of x equals to x squared plus 2x plus 1 by sine x. Pause the video, work out on this for a moment and then check your answer. Okay, so I hope that you have completed solving the question. Now let's check your answer. We will be using the quotient rule for solving this question. Let us say that u equals to x squared plus 2x plus 1 and v equals to sin x. Now let's calculate u dash. The derivative of x squared plus 2x plus 1 will be 2x plus 2 because the derivative of x squared is 2x by the power rule and the derivative of 2x is 2 because we by the constant multiplication rule separate 2 from x and then differentiate x. The derivative of x with respect to itself is 1 and we ignore the constant at the end plus 1 because the derivative of a constant is always 0. We all know that the derivative of sin x is cos x. Now let us plug in these values into the quotient rule formula. U dash v minus uv dash by v squared. We can say that 2x plus 2 times sin x minus x squared plus 2x plus 1 times cos x by sin squared x, and this is the answer or the differentiation of x squared plus 2x plus 1 by sin x. So that's everything about derivatives. If you have liked the video, please make sure to like, share and subscribe for more such informative content.